Sorry, I was still drinking my coffee when I was starting my recording. Yes, what are we doing? We are going to find we're going to derive the formula for the volume enclosed by a triangular prism. So this will be cool. So a triangular prism is made up of two triangular bases. These are the green guys. And these bases are connected by rectangles. So I've got base, nope, wait, base, rectangle, base. So this side of this base is connected to this side of this rectangle, so they form an edge, and then this connects there. Boom. Same thing with the other two sides of the triangles. From triangle to triangle base, there's a face and then a face. Okay, so that's a prism, and you can think of a prism as you start with just a triangle for a base, right? So we're existing in two-dimensional space here. Um, so yeah, regular old triangle. Then we take it into the third dimension. We say let's take this line that's shooting through three-dimensional space, and let's translate this triangle along that line and carve out, if you will, a triangular prism. So I could do that. Hopefully this, yeah, something like that. You kind of keep going for a while, and then you stop. So imagine a triangular prism as basically just made up of a bunch of tiny slices um, that are triangles. Okay, so here's a base and here's a base, and they're connected by an infinite number of tiny slices of well, an infinite number of triangles. All right, that you can think of as tiny slices, and when they connect like that, then they form a rectangle on that side. So you know, from there to there, yeah, that's a rectangle. Okay, so that's what happens when a prism comes into existence. So we can kind of use that basic understanding to think about how would we find of the volume enclosed by that prism. So let me just make this a color that you can see. All right. So, well, let's start with the area of the base. Okay. Um, wow, that's that's cool how those lines are just attached like that. I should do stuff with that more often. Okay. That's cool. So, uh, so area is kind of like volume, but in two dimensions, or volume is kind of like area, but in three dimensions. So, let's find the area of this triangle. So if I've got the fact that this is the base of the triangle, let's do like that. Actually, let me got the base of the triangle. Actually, here we go. This time, third time's the charm. All right, we've got the base of the triangle, and we've got height. So we're just dealing with regular two-dimensional space right now. This is your classic um, area of a triangle is equal to um, 1/2 base times height. Okay, so um, so that's normal. That's cool. So that's the area of this triangle. But then now let's take that triangle and translate it through three-dimensional space to carve out a prism. So what do? You take that area and then you multiply it by this distance. So it's 1/2 base times height times the um, the height of the prism. This distance, the distance between the bases would be called the height. So in order to make this less confusing, because we've got the height of the triangle in the sense of if this is the base, then the height of the triangle is the distance from the base to this vertex here. So why don't we call that the altitude of the triangle? Altitude is synonymous with height in this case. So let's call that the altitude. So that when we say height, we know we're talking about the distance between the bases of the prism. So this is the height. Okay, so let's write our formula. So we've got area, or not area, volume enclosed by a prism. Just write prism. can you see that? Maybe I should do this in white. Volume enclosed by a prism. I'm just gonna write prism so we know that we're talking about the volume of a prism. Is 1/2 the base of the triangle. I'll say like make a little triangle note here. This is the base of the triangle times the altitude times the height of the prism. Or you could write it as, you know, this is the area of the base. So you could write this whole thing as simply the volume is equal to the area of the base, B, times height, the height of the prism, this length here. With the understanding that this area of the base is 1/2 the base times the altitude. The base of the triangle times the altitude of the triangle.